Hello everyone, September the 23rd. Alright, let's do this. Fraction to recurring decimal. Two-integer representation, numerator, denominator of a fraction. Return the fraction in string format. If the fraction part is repeating, enclose the repeating part in parentheses. If multiple answers are possible, return any one of them. Multiple answers? How is multiple answers possible? It's deterministic. It is guaranteed that the length of the answer string is less than for all the given inputs. The long division. I actually forgot how to do long division. So 4 divided by 333, right? So I need to. Oh Lord. So I need to multiply until it's just bigger than. Okay, then we can do long division. And the number of things we need, we added 2, so it should be 0.0, right? And then we say we need 1, that's 63, giving us this was what, 67, right? And then we'll add the 0, and then we'll do 2, it's 666, let's give us 4. And then four, that's the original number, right? So yeah, we have to do this until our remainder is the original number, and that's when it returns back to the original number, because that's when we repeat, right? That's when we repeat. Oh, hold a second. So it's a 4. So it's going to be a 0. So that's going to be a 0. And a 0. And a Z and a 0. And then, oh yeah. So yeah, it's a 4. Right? Hold on. It's a 4. Right? But then I need to add 2 zeros. But we add the first 0 which is this 0, because this is actually have a 0 as well. Yeah, so we add a 0, we add a 0. Yeah, okay. So yeah, we just up until we have this. Yeah, we multiply 10, that's actually a 0. And then multiply 10. Then we will do it. So what would be the coding experience? Well, the coding experience is, if it's smaller, we do 0 point, right? And then we multiply 10. And then we say, if it's bigger, then we'll do it. If it's smaller, we'll multiply 10 again. And then we'll do this. And then we will get a quotient. All right, we'll get a quotient. And we will get a remainder. Right, we get a quotient, we get a remainder. A quotient goes into the result. Remainder is the new value. And then we'll go, okay. So I kind of, the general idea, I have the general idea, but I feel like the implementation wise, this is like a high chance of having error, but we're gonna give it a shot no matter what. So let's use long division. All right, so The ideal is denominator. Int numerator is numerator. Okay. Denominator doesn't change, but numerator will change. And so if wait, hold a second. What if we do, let's say 333? Now, what if we say 400 divided by 333? So it's larger, so I say I go to 1, right? And now I got 333, and now I have 67, and now I say multiply by 10. Then I got a dot. So I actually start from 67, right? And then when I start from this, we always multiply by 10. So this, so we got a 2, got 666, we got a 4, right? It's not equal to 400. So I multiply by 10, so this will be a 0. I multiply by 10 again, then it's the same. So it's gonna be 1.20. Actually, I'm not sure. $1.20. Okay, hold on. It's not right. 400. It'll be 1 again. Ooh, it'll be 1 again. And that's when we start to repeat. When do we start to repeat? Yeah, so this is the same as this, right? Because 40 is 0, 400 is the same as before. But then the repeat, it's not 120, it's 201. So when we have the repeat, we'll put the repeat. Okay, we put the repeat and then we'll do this. So in this case, let me do it one more time. So we start with 0. Right? Well, it's actually start with this. This is 0. And then we have a 0. And then we have a 1. And then we have a 2. And then we have a 0. 40. But in this case it's 4. Right? With 4 we have encounter 4. We have encountered 4. And that shall be it. We encountered 4. These two are not the same example though. Because the original is 4. Yeah, we keep track of all the remainders that we have seen before. Not all the remainders though. Not all the remainders. It's all the dividend. Right? All the divisors. All the dividend that we have. So something that we use to divide. So yeah, but this is start with 4. 4 is the first, but this is 40. 40 is the next one, so it's not 4, right? So basically this one we say 40, well, we get a 0, right? 400, we get as 1, and then next one is 670, we get as 2, and next is 40. So that's why it's a 0, 1, 2. Right? It's 0, 1, 2. And always go back to the very beginning. Actually, no, not necessarily. It'll go back to some place. We have to... we go back to some place. So I also need to know the position. Dear me. We do need to know the position, don't we? So yeah, so actually start with 4, right? 4 start with 0. And then this, and then this. So what I need is a list of dividend and a list of their quotient. A list of dividend and list of quotient. It shouldn't be the list of quotient because I want to find it fast. Which means because I'll push this in 0, 0, 1, 2, something, 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 and then at a one time I'll hit something that's been seen before, and I just need to know what position this is. I don't even need to know what value. I just know the position. This is 0, this is a 1, this is a 2, this is a 3. I know the position, then I know from this towards the end we need to add the parentheses. Okay, that doesn't sound too bad. So in this case, where I start is 400, right? And now we have 670, and then I have 40, and then I have 400 again. So that's the stop. So this will give us 1, this give us 2, this give us 0, right? And then this give us 1, but we have this already. But we cannot use this because this is the start, right? This is the start. This is the starting point. So I have to find the one that's after the starting point. So I actually have to do one more time, and then so this one doesn't count. We start with 670. That's what we start with, and then the next one will be 670. And then this one hits, so we know this is the repeat. Okay, so the first one doesn't count, so we'll get the first one, we get these parts, and then we get the remainder, right? And the remainder times 10. This is when we start. This is when we start. This is when we start. Okay, now we have a map to know its position. Okay, and we have a thing. Okay, so I guess it's fine. Not necessarily. So we just have a numerator, right? So int quotient, initial quotient should be numerator divided by the denominator, and remainder is numerator mod denominator, and string res shall equal to string q plus dot, right? This is the start, and then we don't call it r. This should be the unordered map. Dividend position. Okay, and this is dividend. Is this right? Multiplied by 10. This is the dividend. And then we'll say while dividend position dot contains div. Right? If it do not contain div, okay. I was thinking maybe we can just keep adding, but if we keep adding, there may be complications. So let's set up a vector qs. Right, so if it does not contain, then we say this one doesn't need q. Right, I say int q shall be dividend divided by denominator. Actually, I think we can just push it in. QS dot push back this thing, right? Or divide it, and then div shall equal to div mod denominator times 10. And dividend position div shall equal to 0. So I need index, right? So this shall equal to index. Let's push it this one first. So we get the index, we push him back, we do this, right? And then we go back up, and then we do it until we got a dividend that's inside. Okay, now we know, right? Now we know what dividend is contained. Okay, so from this dividend towards the end. So then what we do is we'll go through them one by one, right? We'll go through them one by one, we push them in, and when we hit the dividend, we hit there, and then we will add a thing. So what we do is for int I equal to 0, I smaller than qs.size I plus plus. Okay, so if I is equal to dividend position div, right? Once it's equal, then what we do is res or plus equal to a left parentheses. right? So we'll do this, we'll add a left parentheses, and the rest will plus equal to string. Maybe I don't even need a toString. I don't know. Let me try. It's QSI. Yeah, I don't even think you need it. And here, maybe I don't need it either. Adding toString does not append to the string. Oh, oopsie doozy. Okay, let's do this. But this, I guess, is fine. I don't know. Okay, maybe it is. So I'll do this, and at the end, rest will plus equal to, I need a right parentheses. And I'll return rest. Alright, let's give this a shot. We can actually have a little bit more. Let's say maybe 403. Usually 7 is a little bit complicated. Now we can actually do this. Alright. Throw at it. Oh wait, hold a second. They have a negative as well. Oh, that is pretty bad. Okay, I don't think we can add directly. Maybe we cannot. Maybe we have to do this. Is that the reason? Nope, not really. We have some issues. Some of them is right, some of them is bad. Okay. What was bad is... Wow, I just randomly picked 7. It's 0, 2, 1. And this is 0, 1, 2. Interesting. Okay, these are edge cases. This... It's a 0. Holy crap. So we are having issues when it can be divisible, right? Basically, it's not repeating, right? It's not repeating. That's our issue. It's not repeating. So in this case, I got the 0 point, and then 1, and I got 10 actually. So this is 10. And dividend is a 0, right? It's a 0. So I need to get out. So, okay, so div had to be not equal to 0. So div is a 0. So we get out, right? And then we just say if dividend is 0, then we don't do this. So if div is not equal to 0, and otherwise we just add this. And we should say if div is not equal to 0, then we add this. So in this case, I don't even go through this. This might be right. My God. That's right. So we do that, and then blah blah blah, and then I think it's here, right? If div is equal to 0, then we just return, right? Otherwise, we will continue. If div is equal to 0 already, then we just return rest. Otherwise, rest plus equal to dot. And we'll continue working on it. Let's try some others. Negative values. Negative values. The length of it should be length. Oh, really? I have no idea that this is so bad. Oh, really? What the hell? Oh man. Oh, this looks bad. Oh, this looks very bad. Alright, hold on. So I handle the sign at the beginning, but here everything has to be positive, okay? So I can do ABS here, just to make sure. So div is positive, and I need to do ABS on the denominator as well. So div int denom is ABS denominator, and then all of this is denominator. All right, let's try this one. What? Length error basic string append. I don't understand. What was wrong? Which one? Is the first one? Interesting. How? Let's go one by one. That's all right. This is 24. Compiles. All right, what went wrong? String is 0. Ooh, that already is wrong. Shoot. Okay, we have to fix that. But divisor is 10. Dan is... Oh, Dan is Dan. That is wrong. My bad. There should be denominator. Alright, so this... Res equal to this, and we shall say okay, res equal to this, multiply. Yeah, how can you do multiply? I can say numerator times denominator is larger than 0, larger equal to 0. If it is, it's this, otherwise it's this. And then We'll say res plus equal to this. Okay, let's try this. We do this. Well, actually, let's have something like that. Okay. Okay, I see what the problem is. I'll do ABS. You know what? Num denominator ABS. Yeah, I think this actually makes things clearer. So we'll do this is numerator and then denominator. This is good, and I don't have to do ABS here, so this is just gonna be numerator, denominator, multiplied by 10. This is not necessary, and then everybody else can just flow as it is. All right, let's see. I mean, this is basically a test on how you can effectively generate all the test cases. Oh, we haven't even done 0 yet. All right, we need to do 0. 0, 1, 2, 3. Okay. Confident? Ugh. Oh. 1 divided by 6. What was wrong? Alright, 1 divided by 6. The way I do it is, so dividend is 10, right? And 10 by 6, I got 1 is 4, so it's 40. And then 6, I got 36. And then is 4 is 40. That's it. So it should be 1. Huh. Okay, let's see, 1 and 6. I'm curious. It should be right. Alright, 1 and 6. Okay. The result is starting with 0. Yeah. And div shall be, oh, well, yeah, div is 10. That's good. So add a z at a dot. Okay, index is 0. So div 9 is 0, and then div index, so 10 index is 0, and I'll push back. This is QS, so this is going to be 1, right? QS, I can see QS is 1. And then the div become 40. That's good. So 40, I push it in. Oh, I forgot index plus plus. Oh my god. Alright, this is a stupid error. Stupid error. It's not supposed to happen. It's not the main logic. It's the auxiliary. Oh, Shoma. I did not. I did not. Dude, I have to compare them. If they are the same sign. I think divide will work. Multiply probably doesn't work, but divide probably will work. Right? I think divide will work. Yeah, let's remove this. And why I cannot use this? I think divide will work. Multiply probably doesn't work. Divide, oh, divide also doesn't work. Lordy. Lordy. I think that's the only scenario, right? Is the denominator is, because if it's a denominator, yeah, denominator can be as well. But we only use numerator once, right? We only use numerator once, so I don't really care. I don't really care. The denominator, oh. How do we handle the denominator? Well, we can keep it negative, actually. I don't really care. We can keep it negative. Right? We can keep it negative. Yeah, we keep it negative. We keep it negative. So we don't change. Okay? Don't change. But we'll do ABS here. We do ABS here. And this, yeah, that's not, because if it's this divided by this, it's gonna be bad. So this we have to be very specific. Right, the same sign. So we say numerator is larger or equal to 0, and denominator is larger or equal to 0, right? Or they're both smaller than 0. Right, they're both smaller than 0. And then we do that. This is a fine. And we'll do so. Actually, I'm not sure how C++ handles negative values. I do not know. But let's hope that it won't be too bad. Yeah, I guess it's fine. Right, that's fine. And no, I like it to be ABS. This will definitely be small, so it should be fine. But you multiply by 10. I think it should be fine. And then this dividend is always positive. So here we should do ABS. I definitely did not use a denominator C++ last time because I never remember we have this stupid overflow issue. Oh, why you do it this way? Dude. Oh my goodness. Don't be so dumb. I just turn them into long and then we can solve all our problems. This is long. Yeah, long. And this is long. This can be int. This is int. And then all we need to do is just change this. Because I don't want to set up another one, so I will just do this. This or this, right? This is numerator and denominator. This is numerator and denominator. That should do, I think. Do I have to go long this? There we go. We do have to go long. Oh man. Alright, extra case. If numerator is equal to 0 or return 0. Otherwise, alright, I can save a few strokes. Alright, this shall be right. Wow, still. Take how many shots? 4? Four shots. Oh, last time was only 1. Only 1 shot. Yeah, I think. Well, I mean, this is because, okay, this is a typo, not typo. This doesn't count. Okay, this is a logic error because of the overflow. So this can be avoided. This is, I mean, okay, and this is an issue with forgetting to consider 0.